everyone and welcome to my channel. In today's video, we will learn about the different kinds of ligands that we encounter in coordination chemistry. So I have divided this video into two parts. In the first part of the video, you will learn about the types of ligands which are classified according to the number of donor atoms which are coordinated to the central metal ion. And in the second part, we will learn about the ligands which are classified according to their donor and acceptor properties. So let's see and learn about these very important components of coordination chemistry, that is the ligands. So let's get started. Hi friends, now we will discuss that what are the types of ligands. So we have already discussed that what are ligands. Ligands are the species which are attached to the central metal atom, and they contain an extra electron, or we may say that they are the electron rich species which donate their electrons to the central metal atom. Okay, now ligands are of various kinds, so the type of ligands needs to be studied. And as I have written here, that ligands have been classified based on the number of donor atoms which are coordinated with the central metal ion. That means whatever is the number of donor atoms, that will categorize different kinds of ligands. So based on this number of donor atoms, we have various kinds of ligands, starting with the unidentate or monodentate ligand. So number of donor atoms is also known as the dentacity, right? Dentacity of a ligand, right? And based on this dentacity, it has been classified as unidentate or monodentate, then bidentate and polydentate. So we will just discuss these one by one. What are unidentate or monodentate ligands? As I have written here, you can see that unidentate or monodentate means just one. So only one atom of the ligand is coordinated with the central metal ion, and it will donate a pair of electrons to the central metal ion. So just one atom will be directly attached to the central metal ion. So what can be the example of such ligands? So the most common example that we have seen in many complexes is the ammonia molecule. Ammonia contains nitrogen which has lone pair of electrons which it donates to the central metal atom. So only one donor atom is attached to the central metal ion. Okay, now another example of this category can be a water molecule. Yes, H2O can also act as a ligand. So oxygen contains two lone pairs, and oxygen here is the donor atom, and one of the electron it donates to the central metal ion, right? Okay, then these two can be classified as the monodentate ligands, which are neutral in characters. Since they do not have any charges, so they are neutral ligands. Okay, then there can be ionic ligands also which are monodentate, like the halogens, fluoride, bromide, iodide. These are also the monodentate ligands because only one atom is there which is getting attached to the central metal atom, and there is a negative charge, so negatively charged, and also among ions is the cyanide ion, which is unidentate because nitrogen atom is the donor atom here in the cyanide also. So these are few examples of the unidentate or monodentate ligands where only one atom is directly attached to the central metal ion. Okay, now next is the bidentate ligands. So what are bidentate ligands? Bidentate ligands, as the name suggests, bi, that means there are two donor atoms. So the ligands have two donor atoms which are attached or coordinated to the central metal ion. That means instead of one, we have two donor atoms of the ligands in bidentate ligands. And the example of such ligands, the very common and popular example is the ethylene diamine ligand. Okay, now looking at the structure of ethylene diamine, we can understand that how it is a bidentate ligand. So CH2 CH2 NH2 NH2. So ethylene, CH2 is the ethylene, and diamine, two amino groups NH2 attached at the two ends, and since we have two nitrogen atoms, So these two nitrogen atoms are the two donor atoms of the same ligand. So we have shown this by arrow. This arrow means the donor atom. Since it is coordinated to the central metal atom, we show it by arrow because they donate the electrons. So on nitrogen we have two arrows showing these are the two donor atoms of the ethylene diamine molecule, which is the bidentate ligand. Another example of the bidentate ligand can be the oxalate ion. Now looking at the structure of the oxalate ion, we can understand that how it is a bidentate ligand. Now as you can see, there are two oxygen, negatively charged oxygen atoms. These two are the two donor atoms of the oxalate ion. So that means it has two donor oxygen atoms. That is why it is a bidentate ligand. So this is the example of bidentate ligand. Next comes the polydentate ligands. Okay, so in polydentate ligands there are more than two atoms, right? So more than two donor atoms of the ligands are coordinated with the central metal ion. So unidentate one atom, one donor atom, bidentate two donor atoms, and in polydentate more than two donor atoms of the ligands are coordinated with the central metal ion. So in this category we will have to deal with the subcategories. So polydentate can start with the tridentate and then tetra, penta, hexa and so on, like this. Okay, so mostly we will deal up to the hexadentate ligands. Okay, so let's just find an example for the tridentate ligand. Okay, so if you look at the example that I have written for the tridentate ligand, the example that I have written is diethylene triamine, also known as diene. Okay, so this is the example. So diethylene triamine means it has two ethylene groups, CH2 here and CH2 here, and three amino groups, triamine. Okay, NH. So three amino groups means it has three nitrogen atoms as shown by the arrows. That means there are three donor atoms. So that is why it is a tridentate ligand, because it has three nitrogen donor atoms. Okay, now let's move on to an example of a tetradentate ligand. So as you can see, the example for tetradentate ligand is triethylene tetraamine or triene. So this compound is quite similar to the compound that you have seen just above, diethylene triamine. And we have now here we have triethylene tetraamine. That means one extra ethylene and one extra amine here, right? So in this example, so if you look at the structure of this compound, so you can see that triethylene means there should be three ethylene groups. So CH2 here, CH2 here. So that means we have three ethylene groups and tetraamine. Tetraamine means there should be four nitrogen atoms. So there are four amino groups, one here, right, and one here, two amino groups, and then the terminal two amino groups. That means four amino groups and four nitrogens. That is why we have four nitrogens as donor atoms, and that is why this is the tetradentate ligand. So four donor atoms, that is the four nitrogen atoms in the four amino groups. So now let's move on to another example for the pentadentate ligand. Now the example for the pentadentate ligand, as I have written here, as you can see, is the molecule which is ethylene diamine triacetate anion. Ethylene diamine triacetate. That means it is an ethylene diamine. We have one ethylene fragment, so CH2 ethylene fragment. Then diamine, we have two amine fragments, two nitrogens, right? Okay, and triacetate. That means there are three acetate segments also. As you can see, this is one acetate, this is another acetate, and this one is the third acetate, right? So we have ethylene, diamine and triacetate. So this is the molecule. It might look complicated, but it is not that complicated. So you write ethylene diamine, then in one of the amino groups you add two acetate groups, right? Here you can see there are two acetate groups, and in another amino segment you can add only one acetate group. So there are in total 2 and 1 3 acetate groups. That is why the name is ethylene diamine triacetate anion, right? Now as you can see, we will mark the donor atoms of the ligands. So obviously nitrogen amino groups should have the nitrogens as the donor atoms, right? And all the oxygens of the acetate ion are also donor atoms. So 2 amino groups, so 2 nitrogen donor atoms, and acetate we have 1, 2 and 3 like this. So we have 3 oxygen negative ions, so which will act as the donor atoms of the ligands. So that means 3 oxygen donor atoms and 2 nitrogen donor atoms. In total we have 5 donor atoms of the ligand. That is why it is the pentadentate ligand. Now as you can see, the example for the hexadentate ligand is the ethylene diamine tetraacetate anion. It's a very popular compound, and it is also known as EDTA. You must have used EDTA in many of your chemical practicals, especially the titrations and during the quantitative estimation of certain inorganic salts and compounds, metals, etc., and as indicators also, and sometimes in as I told, the quantitative calculations. So EDTA is a very commonly found compounds in the laboratory. So this is the structure of EDTA. As you can see, ethylene diamine. So basic structure is the ethylene molecule, and there are 2 amino groups, ethylene diamine, right, amino groups, and on these 2 amino groups we have 4 acetate ions. As you can see, the 4 acetate ions attached onto the 2 amino groups. So 2 each, 2 acetate ions on each of the 2 amino groups. So that is why it is known as ethylene diamine tetraacetate anion. Okay. Now if you look closely, so how many donor atoms we can identify? So we have 2 amino groups, so obviously these 2 nitrogen atoms of the 2 amino groups will act as 2 donor atoms. And then as in the pentadentate ligands, you have seen that also contain the acetate ion. So the negatively charged oxygen of the acetate segment will also be the ligand donor atoms. So as you can see, how many negatively charged oxygen atoms we have for the tetraacetate. So 4 acetate ions and 4 negatively charged oxygen atoms, which also act as donor atoms. So in total 2 nitrogens and 4 oxygen. That means 4 plus 2, that is 6 donor atoms of the ligands. So that is why this EDTA is a hexadentate ligand. Okay, so hope all these examples of the unidentate, monodentate and the polydentate ligands is quite clear to you. And then we will just further this study of the type of ligands onto our next section. So hope this is clear, and hope it helps. Thank you. So I hope after this video you have some sound idea about the ligands, their properties and how they are classified. Please write to me in the comment section if you have any kinds of doubts or queries. In further videos of coordination complexes, we will learn how to name the coordination compounds. So until then, please do not forget to like, share and subscribe if my videos are helpful to you. Stay tuned, and till then, thanks for watching.